Hello students, we'll start with a new topic, that is standard test signals. So in the evaluation of a system can be done on the basis of response given by a system to a standard test signals. Once the system behaves satisfactorily with particular test signals, then it is response to an actual input is assumed to be up to the mark. So whenever we want to study the behavior of any system, we are trying to give some standard test signals to that system as an input. Then we'll study the behavior, then decide what kind of behavior it will give. So in that, so we are going to study types of standard test signals. So in that, the first one is step input. It's also called as position function. Okay. Mathematically, the step signal is defined as r of t equal to a for t greater than or equal to 0 and 0 for t less than 0. So we can define this r of t function with respect to the time function. It's having constant amplitude a. If a equal to 1, then the signal is called as unit step function. Its notation is u of t. Then its Laplace transform is given as a by s. You can observe here in the graph, for t less than 0, the value is 0. For t greater than or equal to 0, value is constant amplitude having a. Next one, next signal is ramp input. It is called velocity function. Mathematically, the ramp signal is denoted by r of t. Then the equation is at for t greater than or equal to 0 and 0 for t less than 0. So the graph of this ramp function is r of t versus t with the slope is equal to a. If a equal to then 1, then the signal is called as unit ramp signal. It is called r of t. Then its Laplace transform is a by s square. Okay. So next move on to the next standard test signals, that is parabolic input. It's also called as acceleration function. Mathematically, the parabolic signal is denoted by r of t equal to at square by 2 for t greater than or equal to 0 and 0 for t less than 0. So graph of this ramp function is denoted with the slope is equal to at. If a equal to 1, then it is called unit parabolic signal, and its corresponding Laplace transform will be given as a by s cube. So next standard test signal is impulse input, that is delta t. It is a signal having high amplitude value for a very small duration of t. So it is the pulse whose magnitude is infinite, we can say, while its width tends to 0, that is t tends to 0 applied momentarily. So area of that impulse is nothing but it is a magnitude. Okay. So if the area is unity, then it is called unit impulse input. It is denoted by delta of t. Here is our tabulation which consists of standard test signals and its symbol and its Laplace transform. Unit step having the Laplace transform 1 by s, unit ramp 1 by s square, unit parabolic 1 by s cube, and unit impulse is 1. These are the samples, symbols of the sample test signals. It is u of t, r of t, and delta of t. Next, move on to the next concept, analysis of first order system. So order of the system is defined as highest power of s in the denominator of the closed loop system. We have discussed this in the previous module. So what are these closed loop system and open loop system? Where in the denominator we have the highest power of s, that is called as order of an system. So in this case, we are defining the first order system by considering one set of RC component as shown in figure. You can observe here, so in this circuit, we are having a R and C. So if one set of RC is there in the circuit, it is called first order system. So Vi of t is the input voltage, Vo of t is the output voltage, I of t is the loop current. Okay. So its equivalent Laplace circuit is denoted as R. Will be R and C will become 1 by Cs. Vi of t will become Vi of S. Vo of t will become Vo of S. Now look into it, that input applied to a circuit is Vi of t and it is given as Vi of t equal to 1 for t greater than or equal to 0 and 0 for t less than 0. So now we'll find the Laplace transform of that Vi of t, that is input, which is given as 1 by s. That is Laplace transform of 1 is 1 by s. So therefore Vi of s equal to 1 by s. From the above figure here we can apply the KVL to that. So therefore Vi of s equal to I of s in bracket r plus 1 by cs. Call that equation as 1. Vo of s equal to I of s into 1 by cs. It is called as equation number 2. To find the transfer function of an this first order system or circuit, so take the ratio, that is equation number 2 and 1, that is 2 by 1. So Vo of s by Vi of s equal to I of s by cs divided by I of s into r plus 1 by cs, so which is equal to, upon simplifying, Vo of s by Vi of s, so we'll get it as equal to 1 by 1 plus rcs, which is equal to 1 by 1 plus ts. You can call this as equation number 3, where t equal to rc is called time constant. Equation 3 represent the transfer function of an first order system, wherein this RC can be replaced by T, where T is a constant, time constant. This is how we can now find out the first order system analysis, how exactly it will gives the transfer function when you have the R and C in the circuit element. Okay. Rest all the things we'll discuss in the next class.